Hey, so everyone knows you have got a 3D scanner, whether it's a desktop laser scanner or a LiDAR for the buildings. Eventually, you will hit the stage where you need to turn your scan data into a CAD model, which is really the most valuable format for 3D work. This is Autodesk Inventor. You have probably noticed I use it in most of my reverse engineering videos. It's such a solid CAD tool for both mechanical parts and construction projects. The number one thing you need in CAD software for reverse engineering is the ability to import point clouds. A point cloud is basically a translucent version of your 3D model, and you can slice it along any plane to create thin sections for sketch tracing. Point clouds are the best reference format for CAD modeling. Sure, you can import meshes into Autodesk Inventor and they run smoothly even with meshes that have 10 million faces, but meshes tend to block your view, making it tough to check if your model is really aligned with the scan surface. With LiDAR scans, point clouds are your only practical choice since a single scan can contain up to 200 million points. The second key feature you will want in CAD software for reverse engineering, especially with the mechanical parts, is the ability to create 3D lines, arcs, and splines. Those 3D lines are what you will use to define the boundaries for surface patching. A lot of complex shapes like car interiors, bumpers, and consoles need to be built using surface modeling tools. The third key feature you will want in CAD software for reverse engineering mechanical parts is the ability to turn watertight surfaces into solids. Imagine spending hours building 3D lines for a car bumper only to have the software fail when you try to convert it into a solid. At the end of the process, you will need to convert your surface model into a solid so you can design the mating features like clips, screw threads, keys, and slots. Because solid modeling is much faster when you are working with hard surfaces. For LiDAR users, the fourth key feature in CAD software is being able to generate 2D drawings directly from a 3D model. As far as I know, besides Autodesk Inventor, the CAD software that can do this includes Autodesk Revit, ArchiCAD, and SketchUp Studio version. In construction, the final deliverable is always 2D CAD drawings. On some projects, I have had to produce more than 60 pages, so having this feature saves a huge amount of time and money. When I make adjustments to the 3D model, all the pages in the 2D drawings update automatically. This is Frecat version 1.1. It can import and work directly with point clouds, but when it comes to mechanical parts, it doesn't support creating 3D lines, arcs, or splines. That makes surface modeling pretty tough, and converting surfaces into solid is still buggy, so I avoid using it for very complex surfaces. Another reason I don't use Frecat much is that larger point clouds slow down the viewport, and the 2D sketching tools are still buggy and slow to work with. Frecat can be fine for hobby projects or occasional modeling, but it's not really up to speed when you are working against tight deadlines. And for the fusions, I don't use it for reverse engineering since it lacks support for point cloud imports and struggle with large meshes. I came across BricsCAD. It's a CAD platform designed for both 2D drawings and 3D modeling, built to serve mechanical as well as construction projects. They promote BricsCAD as software that works directly with point clouds, saves files in AutoCAD's DWG format, and can export models to Rhino 3D, SketchUp, and Revit, three of the major CAD tools used in construction. As we know, Autodesk no longer offers perpetual licenses, and their software is quite expensive, around $2,500 a year for Inventor or a Revit. That makes it impractical for hobbyists. BricsCAD still offers a perpetual license alongside subscriptions, and while the price isn't the lowest, I find it's reasonable. BricsCAD comes in 4 editions: Pro, Mechanical, BIM, and Ultimate. If you are just using it for 3D printing part replacements, the Pro version should be more than enough. If you are creating assemblies or producing 2D drawings, then the mechanical version is the one to go for. If you are reversing a LiDAR scan to create a building model, the BIM or Ultimate version is worth considering. They include features like steel profiles, pipes, walls, columns, and floor slab. Still, these aren't strictly necessary. You could model them with the mechanical tool, but you wouldn't be able to export the model to Revit or SketchUp. To confirm BricsCAD reverse engineering capabilities, I downloaded the trial version and spent a full day evaluating it. At first glance, BricsCAD feels structured like AutoCAD, and its files are saved in DWG format. This is AutoCAD. I've been using it since I was 15, and now at 48, I still rely on it for creating 3D lines in steel structure simulation. For example, here is an industrial pipe scan from Share C1, where I use AutoCAD to locate the pipe center line because it's faster to generating 3D lines. BricsCAD builds model in an AutoCAD style workflow. Unlike Inventor, Fusion, SolidWorks, or Frecat, it doesn't retain execution commands, so once you create a complex object, you can't easily modify it later. Let me show you an example. I start by creating a 2D sketch, then move the work plane to the tip of this line and add a second sketch, a circle. Next, I use the loft command to create a surface. Then I patch the top and the bottom with surfaces to make the model watertight. You could loft this directly into a solid, but I want to show that surface can be converted into solids. BricsCAD even uses the same stitch command as Inventor, though in AutoCAD it's called Sculpt. I subtracted the solid with a box, and you can see it's a true solid that can be used for further modeling. As I mentioned earlier, unlike Inventor, you can only undo commands in BricsCAD. You can't go back and modify a specific step during 3D modeling. Let's import a point cloud of the pool knob from my previous video. BricsCAD supports many point cloud formats. This one is LAS, which I have color green and aligned using Cloud Compare. Just like Autodesk software, BricsCAD lets you define the origin and scale of the point cloud. And here's the point cloud. The viewport performance is excellent, no lag, and you can adjust the point size from this menu. Let's look at the point cloud cropping. You can quickly make a thin slice of the point cloud and use it for tracing 2D sketches. Because it's AutoCAD based, making a closed loop sketch in BricsCAD is fast and reliable. Here I'm creating a solid by revolving the closed loop sketch. BricsCAD can also create sketches directly on a flat plane, letting you use the push-pull command to extrude or cut solids. This feature isn't available in AutoCAD. BricsCAD lets you snap a spline directly onto the point cloud, making 3D boundary line creation easier. I'm using the surface patch command, and I have noticed BricsCAD creates patches differently than Autodesk. The result is a concave surface, similar to when I model a tensile structure. Fortunately, BricsCAD also has a Kunz surface command which produces results similar to Autodesk. To construct a Kunz surface, you need 4 boundary edges, unlike a patch surface, which can be built with just 3. I have tested it, and BricsCAD can convert watertight meshes or surfaces into solids without any error. For the LiDAR scan, this is the 3-floor house from my previous video. With over 30 million points, the viewport performance is excellent. Okay, let's crop the point cloud on the ground floor so we can start modeling the wall. In the BIM version, you can generate walls, floor slabs, windows, and even steel profiles for structural modeling. You can set the wall thickness, height, and alignment, which makes tracing quick and efficient. BricsCAD also offers an X-layer view, letting you see through the point cloud. Okay, next I will create opening for doors and windows. I simply trace a rectangle over the point cloud, then use the window command to create the wall opening. Here's the opening on the back side, quick and easy. You can also use the Slab command to create the next floor level. You can also create section views, which are essential for seeing and modeling the internal walls. And finally, BricsCAD lets you generate 2D drawings directly from the 3D model. Even though it's not as advanced as Inventor or Revit, I think BricsCAD gets the job done. It can project views, generate cross-sections and floor sections, and save them in DWG format. Alright, this isn't a sponsored video. Many viewers have asked me about cheaper CAD alternatives for reverse engineering, both mechanical and construction, and BricsCAD fits that role. There is also SketchUp, which can perform similar tasks, but I'm not sure how well it handles point clouds, since they don't allow trial downloads with point cloud support yet. You should also look at CWCAD. It's cheaper, offered with a perpetual license for about $1,400, but it doesn't have a BIM version. CWCAD also offers CW3D, a modeling software similar to Autodesk Inventor. It costs about $7,000 for a perpetual license. So anything that comes close to Inventor ends up being very expensive. So here's my first thought on BricsCAD, a budget CAD tools. Thanks you guys for watching. I'll see you in the next video.